Girls, how does the value of a in the function affect its graph when compared to the graph of the quadratic parent function? That's a long question with lots of different parts. Let's analyze each part to kind of translate it so we know what it's talking about. First of all, it says a. What is it talking about when it says a? It says, how does the value of a? I don't see the letter a in this function. What is it? It is talking about the 6. Very good. It's talking about the leading coefficient, right? So this 6 is a. How does the value of a, the 6, affect its graph when compared to the graph of the quadratic parent function? What does the parent function look like? Yeah. It's okay, you can use your notes. It's the simplest quadratic function you could have. What does it look like when we write it out in function notation? Let's write it over here where it says parent function. F of x, yeah, equals x squared. So this is the mommy and daddy, the parent, and this is a little baby. They had a baby, and it looks a little like the mommy and daddy, right? It's got the x squared, it's got daddy's eyes, but it also has a coefficient that's not 1. The parent function has a coefficient, you just can't see it. What is that coefficient? 1. So there is a 1 here. We don't need to show it. It's invisible. But over here, the little baby has a coefficient that's 6. So it's going to look a little bit different on a graph, right? On a coordinate plane when we graph it out. Now, you could answer this question without graphing it, or you could actually make a table of values and then plot the points and see the graph. You could do both. Does anybody know how to do it without graphing it? It says, how does the value of a in the function affect its graph? How is the little baby with the coefficient 6 different than the mommy-daddy function? Let's look at the choices first. It says the graph of gx, which is the little baby, opens upward. And we have to think, is that different from this parent function? We'll answer that in a second. The graph of the little baby opens downward. So we'll have to think about that. What might affect it, opening upward or downward? The graph of g of x, the little baby, is narrower. So the parabola is like thinner. Or the graph of g of x, the little baby, is wider. The smile is wider. Now, A and B and C and D are talking about two totally different things. A and B are talking about the direction of the opening of the parabola. So it's either opening upward or downward. Happy parabola, sad parabola. C and D are talking about the width, the wideness or narrowness of the parabola. What about the function
it's going down further.
determines it going upward and downward? What about a function determines whether it is a happy parabola or a sad parabola? Yes, very good. If A, the leading coefficient, is positive, it's a happy parabola. If it's negative, it's a sad parabola. Now, do you see a difference in positive and negative from the mommy and daddy to the little baby? Is one positive and one negative? Is there going to be a difference? No, they're both happy. Yay. Happy mommy, daddy, happy little baby. They're both positive. So opening upward, they both open upward. So that's not going to be a difference. It says select all that apply. In what ways is the graph different from the parent function.
It's decent.
Different. So while this does open upward because it's happy and positive, it's not different from the parent function. So that cannot be correct. The graph opens downward. Yes or no?
Except for D.
Well, what did we just say? It's positive, so it opens downward.
That doesn't make sense.
It goes upward. So it says the graph opens downward. Does this graph open downward? No. So that also cannot be it. Because there's nothing different about the signs of A. They're both positive, so nothing's different about them. So those are not affected. Yeah?
If it's positive, it goes upward. So why did we cancel out upward?
Good question. We said that can't be the answer because while this does open upward, so does the parent function. And this is asking, in what ways is the graph of g of x, the little baby, different than the mommy and daddy? Okay? So, even though this does open upward, that's true, it doesn't differ from the parent function. Choice C says the graph of g of x is narrower. Choice D says it's wider. Okay, so what makes a parabola, or the graph of a function, narrower or wider? What determines? Yes.
Whether a number is higher than
Then what?
1.
Yes, very good. The parent function, we said, does have a coefficient, which is,
X.
nope,
Oh,
1. But this little baby function has a coefficient that is higher than 1. Well, how does that affect the graph? Does it make the parabola wider or narrower? And if you have it in your notes and you want to check your notes, you can do that.
No.
It makes it narrower. Very good.
That was the bigger number.
Yes, because when the coefficient is higher than 1, when the leading coefficient is higher than 1, it makes the parabola shoot up really fast and really high. When the leading coefficient is between 0 and 1, like 0.5, 0.4, 0.89, it's going to widen, it's going to stretch out the parabola a little bit more. So this, being greater than 1, is going to make it narrower. So how would we, if we were showing work for this and handing it in to me, how would you explain this answer? Because we didn't have to show any math. We didn't have to draw the graph to solve this. You could, if you did draw the graph of the parent function and the little baby, that would be showing work. But you could also just explain it verbally because we don't technically need to draw the graphs to compare them. Yes?
I don't know how to explain it.
Yeah, go ahead.
It would be narrower because it's higher than
That's all you have to put. I love that. That is a way to show work. So all you have to write is the choice, or the correct answer is narrower because A is greater than 1. That's perfectly showing work with an explanation. Does anybody have a different function here that you want to analyze before we move on, or is yours pretty much the same as one?
they're all the same.
Are they all 6, or are they just all over 1?
They're all over.
They're all over 1, okay, so it's asking the same thing. You guys ready to move on? Okay. Oops. Last question. How does the value of A in the function affect its graph when compared to the graph of the quadratic parent function? Same exact question, different little baby. Oh my goodness. Is different than the parent function in the direction it's facing or the wider and narrower situation? Both. Very good. How do you know it's going to be both?
Because it's negative, it's going downward, it's below 0, it's going wide.
If it's between 0 and 1. Yes. He's noticing that both two things are affected. So that's why it says select all that apply. So in this case, we're going to have to select two of them. Now, the parent function is a happy parabola, right? It's got a positive leading coefficient, so it's happy. The little baby's crying, it's negative. So it's very sad. That's a sad parabola. So, which one do we select for that one? Yeah.
Wider and downward.
We didn't get to the width yet. Downward is correct. Upward would not work. Are you getting this, Emily? I know you weren't here for this. Okay. Can I pick on you guys and ask somebody to interpret why we chose downward and not upward? Emily, do you want to tell me?
No.
Okay.
But
Thought you were raising your hand.
I would get
Okay, we're gonna get to that in a second. Yeah. So I'm gonna explain that one. I know you can explain it because you got the right answer. Angelique, can you explain to me why we chose that the little baby opens downward and not upward?
It's going downwards because it's negative.
Yeah, it's going downwards because it has a negative leading coefficient. It doesn't, for the upward or downward, it doesn't matter what the value of the digits of the coefficient are. It just matters if it's positive or negative. That's the simplest way to describe it. Okay, so now, and this was part of the lesson yesterday, the narrower or wider is a little bit trickier. It's not as easy as just being like, positive is happy, negative is sad. This one, and when you do watch the video, you'll see it. So the parent function looks something like this. When the leading coefficient is between 0 and 1, and don't worry about the negative right now, it is gonna open downward, but it is between 0 and 1. Let's just for kicks pretend that this is actually positive, just so I can compare it with the parent function and not have to worry about it facing downward. Can we just do that for a second? In terms of the narrow and wider, let's just pretend it's positive just so we can work with positive numbers because the narrowness and wideness will be the same. Oh, what did I just put my hand in? Okay, so it's between 0 and 1. It's a decimal number. It's almost half, right? So it's between 0 and 1. That is going to open up the mouth of the parabola wider. And it'll look something like that. You could absolutely make a table of values where you punch in some inputs, square it, and then multiply it times that coefficient. You'll get an output and try to graph it. It's going to be really hard to graph just because it's decimals. All we're doing is analyzing like the behavior. What is it showing on a graph? So I'm just estimating this, but because what we learned yesterday, when with simpler numbers like 0.5 would be much easier, right? It shows that the output travels upward more slowly. So because it travels upward more slowly, see how the lower than 1 number kind of slows the output down? That's what allows it to open up wider. Because it doesn't shoot up as high.
Oh, okay.
Now, if this were the other one that we just worked with, like the 6x squared,
this is congruent to this.
that
so you
would cause
like I did here. 0 minus a is
a much narrower happy parabola because after it's being squared, it's being multiplied by 6, so the output shoots up higher at a much faster rate.
Makes sense.
So if it's between 0 and 1, it gets wider.
Not just saying it's a
If it's higher than 1, it
Now
gets
this
narrower.
Can change.
Does that make
This is
sense?
not necessarily- Like I could
Okay.
have drawn this to be 1, and this to be a 4. and
Totally
so
good on these?
Like,
Yeah.
it doesn't matter.
Doesn't matter.
It's just the relationship that stays, because it's gonna be
Okay, so
A
do you need help writing the explanation for this part?
A by C.
Okay, so I would say something, okay, can somebody explain it?
That,
Yeah, Ricky.
It's downwards because it is a negative and it's y.
Okay, so let's pause there. So we would explain that it opens downward because the leading coefficient is negative.
Yeah,
It's just like, I don't know what to do.
yeah.
I was just confused because it didn't say that.
Yeah, it doesn't specify that it's looking for the distance, but it is saying that these two segments are equal to something.
And then
there's
can
something
somebody
that
else
needs a
explain the
distance.
wider part, Kelly?
It's wider because it's
Very good. It's wider because the leading coefficient is, thank you. Between 0 and 1. That's good timing.
Figured out help.
What's that? Yeah, you're gonna turn the work in. That's my new 4th quarter rule.
Why did you have that all year? You had it all year for us. You had to do work.
And we
That's
did-
because I was really mean last year the whole time.
And you did give us 4 questions per homework.
You guys are looking.
I mean, you're always supposed to show work, but I noticed that like a lot of people were handing in their homework, submitting homeworks on Canvas or Satis, getting hundreds on them, and I was like, I know that you don't know how to do this, so how are you getting hundreds? And they were like getting answers from their friends, photo math, or whatever. So I'm like, well, now I need to see work.
Also, we didn't have 4 questions on our homeworks.
Huh?
We didn't have 4 questions on our homeworks, we had like 15.
I know. It's very sad. Okay, next question. Oh, look at that table of values. That is intense. Over what interval is the function increasing? And over what interval is the function decreasing? Now, do you guys agree that, okay, well, first of all, is this gonna be a happy parabola or a sad parabola? Sad parabola. So it's going to look something like this. I'm not gonna worry about how wide or how narrow it is. I just wanna see that it's a sad parabola. I'm not worrying about where the vertex is. I'm not worrying about putting it on a graph. I just kind of wanna see what a sad parabola looks like, because when I read this from left to right, well, the vertex is kind of important. You do want to know the axis of symmetry, which we can see right here. We can see that the symmetry happens before 0 and after 0, or before the origin, after the origin. So that means that it's split down 0, 0, or the y-axis, okay? Now, reading it from left to right, I'm gonna pause when I get to the turning point of the vertex, because I just wanna see the behavior that's being consistent with what's happening here before it changes. Do you see how once it hits the vertex, it's gonna start changing and going down? So on the left side, when I read it from left to right and stopping at the vertex, what is the behavior of this function? Is it increasing or decreasing? From left to right, is this going up or down? It's going up, right? If you're reading it from left to right, this is going up. So it says, over what interval is the function increasing and decreasing? Well, so far we see that the function on this side of the y-axis, it's increasing from left to right. So over what interval is it increasing? How would we describe that interval? The interval is described in terms of your x values. So what x values cause the function to increase? How could you describe those x values? Would you say over all of the x values it's increasing? No, because when you get to this point, it stops increasing and then goes down. So what's special about the x values on this side? How would you identify the x values on this side of the y-axis? What would you call them? What would you call the x values on this side compared with what you would call the x values on this side? Okay. What do all the x values on the left side of the y-axis have in common? They're negative. Very good. So these are negative x values. So the function is increasing over the negative x values, right? Now, that's not your answer, but it's so close to the answer. What we're doing is we're just kind of describing the type of x values. Now, it says type an inequality. Well, how can I represent negative numbers in an inequality?
X is less than 0.
Very good. X is less than 0. That's how you describe negative numbers with an inequality. So, reading from left to right, when the values are less than 0, the function increases. God bless. I know. Let's show work for this part. Somebody describe how we would explain this. Yeah.
Since it's negative, x is less than 0.
Okay, yeah. I would say even more specific, I would say when you read the graph from left to right, you notice that the function is increasing over the negative values of x. Something like that. And then you would say that means that x has to be less than 0. Why aren't you guys writing? You can say it in your own words. You're looking at me like, oh, can you say that again so I can write down exactly?
I don't know what I write at all.
Okay. So let's talk about it because I definitely need you guys to be able to, like, I love doing this with you, but if I do it with you and explain the whole thing and then you still can't explain why the answer is what we got, then I don't know if you learned.
I wasn't paying attention.
Okay. I love the honesty. Okay. So when you look at the graph, now you can just look at the output values here, and you can see that as x approaches 0, which means we're reading it from left to right, as x approaches 0, these numbers are getting higher. Negative 1.2 is lower than negative 0.3. It's very hard to visualize with negative decimal numbers. That's why I drew the graph, because I knew it was going to be a sad parabola, which means, and then the vertex is 0, 0. So it doesn't matter how wide it is, because even if it was like super wide, it would still be increasing. And that's all it's asking for. So how do we show work for this, that x has to be less than 0? When you read the graph from left to right, the x values that result in the function increasing are negative.
For my number, it's positive.
Yours is positive?
Yeah.
Really? What is it? What does it say here?
This is positive. X equals 0.8x squared.
Okay, so yours, does anybody else have a positive one?
I have one.
You do. Okay, so yours is gonna be the opposite.
If it's positive, this is what?
Yeah, if yours is positive, it's gonna be a happy parabola. Is your vertex the origin? Is that where there's a shift from in symmetry?
Yeah.
Okay, so yours is gonna look something like that, very much like a parent function, but it might just be like wider or narrow, doesn't matter. Because when you read yours from left to right, so yours is gonna be the opposite. So when it asks you, when is it increasing? Notice that yours is increasing on the positive side of the y-axis, on the positive side of 0. So your interval, your interval would be x is what? Greater than 0. This is for Emily and Ricky.
I already did mine.
Okay. If your function is positive, if the leading coefficient is positive, then it's increasing when x is greater than 0. It's increasing over the positive side of x. Yeah. Or the positive side of the x-axis.
Okay, that was the one.
So I'm going to go back to this one for a second, and then we'll go back to yours, okay? So now it's going to ask, when is it decreasing? So it's decreasing here, from left to right, it's decreasing here. How would we, how would we represent that with an inequality? Yes, x is greater than 0. And then your explanation would be something like, the function is decreasing for the positive values of x, which we would represent as x is greater than 0. Now Emily A and Ricky, when it's asking you when is it decreasing, yours is decreasing on this side, so what inequality would you use?
X is less.
Yep, x is less.
Just swap this on.
What is that, topic 7? What is it? Oh, all the work shown? Okay. Okay, let's go to, this is question 3, so we have one more to do.
And there's another part for that.
Oh, well, we already said it, we just,
You're supposed to use whatever they say exactly.
oh, is it?
Yeah.
Great.
But
Okay, so in my question, now I have a positive A value, which is gonna be what Ricky and Emily just did. And you will probably have a negative. You got another positive one, so it's the same answers? Oh,
I got a negative.
you got a negative. So yours, if you have a negative a, so if your function is a negative a, x squared, whatever a is, it doesn't matter. If yours is negative, that means your parabola is going to be sad. If your function has a positive a, or positive leading coefficient, your parabola is going to be happy. I want you guys to do this one on your own, and if you need help describing your intervals or getting your intervals correct, please let me know.